walkthrough for the exercise debugging product. So at the top here, we have our starter code followed by the debugging tips, which you guys should definitely have a read of, including the Comp 1511 debugging guide. And then we have the task. So this exercise takes in integers as command line arguments and calculates their cumulative product. However, if the number is 0 or not an integer, it's not added to the cumulative product of command line arguments. Currently, it has some issue. It's our job to figure them out and fix the code. And we have our examples here. And if you're not familiar, argc stands for argument count, and argv is argument vector, which is an array of strings storing all of the command line arguments. And we have some things, so we might find the toy function in the C standard library useful. Cool. And we may assume that argv0 will always be the program name. Awesome. And then we have our style and auto test commands. So on the left here, I've just got the starter code. So let's compile the program and see if we get any immediate errors. Okay, so we can see we've got a comparison between a pointer and an integer. So in our while loop condition, we're doing while I is less than argv. Immediately we should know that this is incorrect because argv is an array and we want to be comparing it to an integer. So we should be using argc in this case. And looking at the second error, subscripted value is not an array, pointer, or vector. And we can see that we're trying to use argc as an array, which is incorrect. We should be using argv. So let's change that and let's recompile and see what happens. Okay, so it seems to compile. So let's run the program. Let's go 0, actually we'll exclude 0, we'll just go 1, 2, 3, 4. And nothing is happening, so let's quit out of this. Okay, so it didn't let me print the things, but nothing was happening, which makes me think that we're in an infinite loop. And that's correct, because we have a look at our while loop here. There's nowhere that we're actually incrementing the value of I. So let's do that. Recompile our program, rerun it, and see what happens. Okay, so the product is simply 0, which is not quite what we want. In this case, it should be 1 times 2 times 3 times 4, which is 24. We can also see at the end here, we're missing a new line character. So let's just go in and add that. Okay, so the product is always 0. Let's have a look at what's going on. So we set a variable product equal to 0, and while I is less than argc, so for each command line argument, product equals to product times the integer of that command line argument. And then we add 1 and we keep going. Well, in the first case, we have the number 1, and it would go 1 times 0, which equals to 0, and it's going to keep looping over that. So we can see the issue is that we've initially set product to 0, and instead it should be 1. And now let's recompile and rerun and see what happens. And it is still 0. That is interesting. Okay. So we're starting from I equals to 0, which includes the program name. And if we look at the man pages for the toy function, let's look at the return value. Where is it? Somewhere in here, it should be saying that it returns 0 if it's given a string, which is not quite what we want because the first command line argument is always going to be the file name. And if we're starting from 0, the first thing it's grabbing is /debug product. And when it calls a toy on that, it's going to give it 0. So what we can do is we can start at the index of argv, which is 1 after the program name. So let's recompile and see if that fixes it. Okay, so it looks like it fixed that case. Let's test some of the other test cases in the spec. So we have 0, 1, 2, 3, 4, 5, and we can see that we're now getting 0. And if we have a look at the spec, it does say if the number is 0 or not an integer, it's not added to the cumulative product. So we need to do a check to see if the command line argument given is 0, and we can do that by writing an if statement. So if a toy of the command line argument equals does not equal to 0, that's when we want to actually add it to the cumulative product. And then in both cases, whether it is 0 or not, we do want to increment I. So let's recompile and see if that fixed it up. Seems like it did. Let's test it on the negative numbers case. So -5, 1, -1, -2, -10. That seems to match the spec. Let's grab something with some strings in there. So this will check that our if statement is working as expected. -200, and that mark matches the spec. And let's just check this 0 case. Okay, so this isn't quite working as expected. And we need to have a think about why this is going on. So we're setting product initially to 1 in all cases, even when there's nothing to multiply, which technically should result in 0. So a way to get around this is, instead of setting product to 1 here, what we should be doing is, as soon as we see something that we want to add the cumulative sum to, we can do a check. So if product equals to 0, we want to set it to 1 so we can actually start multiplying it. The reason why I put an if statement is because if we just simply did product equals to 0, we're going to run into an issue of it resetting every single time. So you can see here it's stuck at 0 because it's going to set product to 0 and then try times it, and it's going to override. So instead of doing this, we'll just do an if statement. So only on the first instance where we hit the first integer, it will do what we want. So you can see it works for this case and it works for the all strings case.